So luckily for me, I was actually able to take an early look at some of these slides. And one of the great things you talk about was the fact that most production hallucinations that we see aren't really the model making things up anymore. Instead, it's the case that these errors they tend to be extrinsic. Right? The model is given a ton of real context and then making mistakes around how it's reasoning about that context, whether in the search context or maybe in the tool using context. And so this is why I'm really excited to invite my friend Julia today to talk a little bit more about that. So she's the co-founder and CEO of Quotient AI and formerly the director of data at GitHub Copilot. And I think for the most part, you worked on the evaluation system there. And so this is a lot of sort of learning that we can probably take from. And in the next 30 minutes, we're mostly going to go over two really big concepts I think are really important. The first one is that we want to break up the retrieval evaluation with the generation evaluation. Right? And the idea that we want to use these reference-free metrics because in production, we don't have them. And the second part is how do we use these kind of judges to monitor this kind of data in real time. And so as always, Marian has shared the link in the Zoom chat for questions. Julia, take it away.
Thank you so much for the warm intro, Jason. I'm really happy I get a chance to meet you all and talk about the challenges that we've seen both with our customers and actually also building our own agents and models and how we settled on solving them. But first off, just a little bit more about myself. Jason did already such a great job introducing me. But as he said, before starting Quotient 2 years ago, actually, we just had our 3-year anniversary this week. I was the director of data at GitHub Copilot, and I led the team that built the evaluation infrastructure for that product. And that gave us the idea for how to start Quotient because it was 2023, and we had we're just seeing these like new AI applications. I don't think agents was even a word back then, or at least in this context. And we were like, oh, like you get these non-deterministic systems that are harder to measure. How do you build a way to make them behave reliably? And that was something, again, we had worked on at Copilot, obviously in a slightly different context than what we're focused on now. That was like code generation. And we set off to build Quotient to help developers build reliable AI products. Before this, my background is in AI, ML, data science, all the buzzwords at their time, and my experience in tech, legal, insurance. In a past life, I was a physicist. And about Quotient, so I started 2023 with Freddy Vargas, and we're focused now on building the next generation monitoring layer for applications. We monitor, analyze, and improve AI systems, and we use a combination of foundational and in-house models to analyze data coming from agents and identify critical failures. And we focus particularly in AI search, legal AI, and sales agents, and that will color the examples I show in this talk. Which are actual things we ran into with customers for building. So I'm happy to dive in. So as Jason hinted a bit, I want to spend a little bit of time just saying the tone about what we define as a hallucination, because this is a conversation I find myself having with a lot of people as we start chatting about the issues they're having in their applications. I think pretty much everyone agrees that hallucination is something that occurs when an AI model, an LLM, generates an output that doesn't really make sense. It's either fabricated or incorrect information. It straight up doesn't look correct. But there are actually like two different types of hallucinations, and I find myself that a lot of people only focus on the first one, which are intrinsic hallucinations. And that's what I define as hallucinations that are due to the model's training data and its representation of the world around it. It's basically things like when you prompt a model without providing an external context, like you just ask a question, and you get a response back that's just completely fabricated. And there's an example here in the top left. I think this circulated on Twitter a year or so ago when there was some hallucinations around the James Webb Space Telescope that did or did not take the first image of an exoplanet. And there are tons of examples like this. Like, I'm sure you all have a favorite one that you've shared with your friends. But in general, it's meant to indicate, hey, the model just looked and it's just based on its training data, tried to answer a question, and it really didn't get the right answer. But there's this other type of hallucination that it's actually the more common one these days. It's because we are building systems in which we're providing agents with external context from either search or retrieval, or like tools, and we're providing the models with extra context, and the model uses that context in generating the output, and then misinterprets information or misuses information from that context, and then gets the answer wrong. So there's examples, again, circulated in the social media about, I know, like Gemini looking on like threaded threads and answering questions based on that. And there were definitely situations in which very interesting information was presented as facts. But the idea is, hey, you provide a model with some context and the model output contradicts or deviates from that information. And that is actually what we see in actual like agentic systems more often than not. And pretty much everyone I talk to experiences this type of extrinsic hallucinations in their product. This is also the answer to the question, are we solving hallucinations by training smarter models? Ultimately, you are solving for intrinsic hallucinations, and you are definitely giving yourself a leg up in having fewer extrinsic hallucinations, but they still happen. So most hallucinations in production are extrinsic. This comes from the fact that a model that has incorrect reasoning over real context. We've also seen issues like context rot, where you have you're basically like, the more context you have, the harder it is for the model to parse it. That's also been a topic of discussion that I think is very important. And it's especially hard, and the reason why it's really hard to control for this before you ship something into production is it's really hard to control for this when users supply their own data. And I think this is very important because actually most applications right now, most agents rely on data that's extrinsic to their system. Either the user brings their own documents, or you provide like a web search API to your agent, or you provide a new list of tools to your agent. It's really hard because you don't have control over that corpus of data to develop a robust system that can handle that diversity of data. So for that, then that means you need to test for this and evaluate for this and continuously monitor to make sure that you are providing both, you're providing like the expected reliability with your agents, especially as users or the agents have access to external data. So that's why something I want to talk about first is how to have like a systematic approach to evaluating these systems. Like we call an augmented system, retrieval augmented, search augmented, I've seen context augmented, but for these general augmented AI systems, how can you find critical failures? One of them being hallucinations. And for that, you need to answer two questions. One is, was the right information retrieved? Like to the extent that you had a user query and you're looking to answer it with like from a corpus of data, did the search component of your agent even find that relevant information? And did it provide sufficient context to the model? Because that is the first step. If you didn't give your model the ability to conceivably answer a question, then nothing after that matters. Then the second question is, did the model use the information or the context provided correctly? Assuming that it had access to that correct information, did it stay grounded in the retrieved context, or did it fabricate some facts or make extrapolations or other issues like that? And what's interesting about these is that in order to answer these questions, you don't need actually the ground truth answer. You just need to be able to reason a structure way through these two steps. And this is why things become interesting here, because if we don't need a ground truth answer, that means this is something we can do in real time on the fly in production environments, and evaluate agents as they run, which is not something we could do if we needed like a benchmark or something like that. So this also opens up some possibilities, has some challenges and a lot of opportunities here. I also want to justify a bit why I'm also talking about the retrieval here, whereas most people focused on, okay, I just need to make sure that my generation was bad. And I kind of hinted at this a little bit, but basically the idea is if you don't provide your model or agent with the right context, it will fail. It will fail pretty much 100% of the time. And something that we see in actual production environments is a lot of hallucinations. I would say the 80-20 rule applies, start off with bad data. They start off with the data not being available in the upstream system, with the data being out of date, and they start they start a bit later at the retrieval step. But in order to catch, in order to know that, you need to look at both. So basically, you need to debug the whole pipeline step by step. So here's how we do it. I mentioned the first step is to evaluate the retrieval. What you want to do is like break things up systematically and basically say, hey, like, you want to answer this question in a satisfying manner? Did the retrieved documents contain the information needed to answer the query? If yes, you're good. You can evaluate the generation. If no, you need to dig in there. Like, did I have a bad retrieval or did I not have the data available? And what you want to do is actually monitor two metrics at this step. One is context relevance, which is the % of retrieved documents that was relevant to the user query. You want that to be high because you don't want to provide a model with a ton of irrelevant documents. And you also want context usage. You also want the model to use most of that context that was provided. So if you're thinking about high quality RAG, you want these both metrics to be high. And of course, you want to make sure that, again, the retrieved documents are relevant to answering the user query. And here I share, if you want to go back to these slides later, this is basically like, hey, you want to figure out which of these failure modes are, to the extent like that the query was, the retrieved documents were not relevant to the query. Was it a bad retrieval, which means that the relevant information exists, but it was not retrieved? Or was it bad data? Did you straight up not have the information in the database? I will say like these are the hardest questions to answer from this entire presentation, mainly because the way to answer them means that you have to check the corpus, the corpus of your data first. You need to see if it actually contains the information you need. And if it actually contains the information you need, then you're just not able to provide it. So the challenge here is you can only do this for like reasonable corpuses of data. You can do it for web, and you can do it for, I don't know, if you have like thousands of terabytes of data, that you can, it's harder. The bigger your corpus and or like if your corpus of data is user defined, as I said, these things become a lot more challenging. And I think I'm gonna address that in a little bit, but this is definitely a challenge, is how do you know that you even have the right information in your data set? Now to answer the question about like how do you evaluate generation, again, this can be very systematic. The top line question you want to answer is, did the model fabricate information not in the retrieved documents? If the answer to that is no, you're all good. Your answer is grounded and supported. If you actually did fabricate, the model did fabricate some claims, that means that you probably have some hallucinations. And usually hallucinations come from a few things. One, there's like poor context quality. We're sort of providing the model with context that's noisy, that's long. I see a lot of use cases right now with agents that like scrape information from the web or from databases. Then or like it comes from OCR. That can be like problematic in terms of the quality. There are also situations which the model misinterprets a query, misinterprets a user's intent. Users now are providing less and less instructions to models and agents, so that can definitely happen. And sometimes things just get missed out, especially if you provide very long context to the models. And we do see this. We do see like error rates go up as like context size goes up. It makes sense. Like models need to parse that information, and sometimes they miss key things out. Just going back to, and also, so just kind of stepping back, the way to evaluate like these augmented systems, you need to evaluate the retrieval, a generation, and then you also need to, if things look good, or if you're still having problems with like the retrieval, for example, you're gonna probably end up spending a lot of time figuring out, do I even have the right data, and how do I deal with that? And that's both a technical question, and if you're building production applications and agents, that's also a product question. Like how do I even get my users to, I know, provide better data? But doing this proactively actually will help you out. Like doing this before you put something in production, doing this during onboarding, for example, is something that can help you address problems in the underlying data before you even go through the whole process of retrieval and generation, especially if all those steps happen in production. So this is something some folks want to try, which is you do something I call like proactively auditing your corpus. And you have your full document set, basically what's in your vector DB. And you have a set of representative queries with ground truth answers. And you can think about, let's say, FAQs or something like that you're building, like a Q&A agent. And then the only way through this is you run an exhaustive brute force search for each query, and then you can see whether the query can be answered using the existing corpus. Obviously, this is going to be a subsample of a limited set of data, but actually a lot of folks catch gaps in their data by doing this, like for example, as an onboarding step. Like if you're onboarding an enterprise customer, and the idea is like, hey, you're gonna run this Q&A agent on your like in your data warehouse, this step could save you a lot of debugging later on, especially because, again, anecdotally, most augmented systems, RAG, search fail because the data is not there. And then also like fixing the model, prompt engineering, whatever, won't help you if the data is not there. This works and doesn't, depending on what your system is. It works if your system is small and focused, if it's like an internal knowledge base or product docs or things like that. It helps if you have an onboarding step when you're, again, like bringing a new user or a new set of documents to the application, because then you can do this exhaustive check. It doesn't really make sense for a large system, and you can straight up not do it for anything that's like the web. You can, the only way to do that is to basically have your agent running production and then monitor it for metrics like metrics that measure the retrieval and the search on an ongoing basis, and then see if where the problem areas are as you're running these in production. But it's very hard to do this like a priori exhaustive search for some of the more complex agents. And that's actually what I'm gonna talk about in the next section, which is, okay, so I actually have a system where I can't do anything like this. How do I monitor it in production in real time? Because that's one, I want to do that anyway, but in some cases, that's the only type of evaluation I can do for my system. Before I jump in, I put a bunch of QR codes in this entire presentation. So you also get access to these slides, obviously, but I basically everything I showed in the first section, it's in this educational primer I put out about how to detect hallucinations. It talks about that, provides a bit more details, and you can read up more on that. But going back, how, like, let's talk about something practical where I'm thinking about AI search. For context, AI search is when you provide basically like your agent can access the web. It can search queries on the web, it can extract information, and you want to make sure that you're building a reliable agent around that. And there are few providers for a search APIs. We work with Tavili, but there are a few others, Exa, Perplexity, U.com. In general, they all look kind of the same, but they provide a challenge of you're providing context to your agent that you can't control really. And how do you make sure your agent is behaving correctly and it's getting the correct search results or relevant search results, and then how do you continuously improve it when basically you can't really benchmark for that really. So this brings out like the meta level point of you have these systems, these AI agents with search, without search, that are dynamic because they need to handle arbitrary user inputs or queries. They do like real-time web crawling. And this is why I am here talking about this, because that is exactly what we need to solve for. So we need to, we basically focus on building evaluators that look at your agents and say, hey, there's a problem with your search, or there's a problem with your generation. Basically, we automated everything that you saw in the first section to automatically run on logs and traces from agents. In the context of web search or web-based AI search, the challenge is that, as I mentioned, the web is constantly changing, and the users can make arbitrary queries, which are the two your two nightmares if you're building an agent. Is like changing context that you can't control, and users who will query whatever they want. If you're thinking about like how to evaluate these types of agents and system, we need to solve for these two problems. We need to make sure that our evaluation system can keep up with a changing context, and we need to make sure that we can evaluate the generation or the model outputs or whatever the agent does, given this changing context. So we can't have anything static, basically, and everything has to be real time and everything has to be reference free. And we need to have the ability to do it very accurately. This brings up this need for having reference-free evaluations, and and these are essential basically in these real-time production environments, because again, when your underlying data and context is changing and your user queries are changing, but also if you want to do it at all on the fly, as your users are talking to your agents or using your system, you can't rely on having golden answers to your queries. So you need to basically be able to measure things like document relevancy and hallucination rate in real time. And these are actually the flagship metrics that folks who are building search retrieval augmented agents rely on. These are two metrics that they track every day. They have dashboards, they monitor these metrics for, because they basically answer those two critical questions I mentioned at the beginning, which is how relevant is my context? How good is my retrieval working? And am I making stuff up? Is my agent making stuff up even when the retrieval works? So this is all theoretical, but I do want to share an example, and you're welcome to, I haven't tested these QR codes. Hopefully if you scan that little the little dinosaur in the corner, you will be brought to a Notion page with a walkthrough for how to do this. I'm not going to pull it up. I'm going to stick to the slides, but what hopefully you'll find is a walkthrough of how this all works in practice. So Tavili put together this legal research agent that uses Tavili for AI search, for web search, and uses Quotient, our product, for automatically measuring their search and generation quality. And this is a very simple, straightforward example that highlights, one, how can you even provide this eternally changing context from the web to your agent using an API, and how you can monitor the quality for the generation of the search and a generation on the fly with reference-free metrics. And why is this? Why did I pick law? Why did we pick law? Because what we see more and more is that there are these applications of agents that are coming out more and more where there's actually real world harm or risk from having things like hallucinated answers or relevant citations in your agent outputs. And I think law is the perfect example for that, because there's this issue of like jurisdiction, and this issue of using like case examples correctly in reports. And there's this issue of citing every claims that you're making in the reports that I think in other agents, they're like nice to have, like quality of life type of problems. And for something like a legal AI product, it's existential. Like you can't have that happening. So step by step, how would this work? Well, Tavili has a very simple API. You basically like search legal sources using Tavili, use a natural language query, like what is the standard for granting summary judgment under Rule 56, and you provide it with some particular domains you want to search, and it basically looks around those domains and extracts the information it finds relevant. That is all very straightforward. Then in this example, we used OpenAI an OpenAI model. I forget what we used. I think we used 4.0 Mini. Yeah, we used 4.0 Mini to generate like a memo based on the research that was done for the particular query. It has like a little executive summary, a legal analysis, and a conclusion. It provides all the sources. And you get something like the thing on the right on the output. And what we want to do as this agent is running, we also use Quotient to automatically analyze the outputs coming from that agent. And we look at these memos, and we basically say, is there any information in that output that was unsupported by the information that was provided to the model? And in this case, the context that goes to the model are the extracted pages from the websites that the Tavili API found. And you can actually go back to the memo. You can also see, looking at this memo on the right, there's a bunch of things that would make me nervous. So if I was building this agent, for example, like, are those links in the bottom that I'm providing even correct? Because I know that's like a big source of hallucinations in this type of agents. And that is one of the things we check for. And again, what's under the hood, and I'll go into a few more details in 2 slides, is we basically analyze and detect. We basically run that analysis from the first section of like, did I retrieve relevant sources given the user query, and did the output was the output all supported by the information in that context. And this, you can keep track of this in real time as you're running or building. But basically what you end up wanting to look for are those like 2 flagship metrics of hallucination rate and document relevance, because those will basically give you as complete information as they can about your system in terms of, is my search working and is my generation working. A bit of what's happening under the hood. Again, as I mentioned, this is just a programmatic way of doing of automatically calculating document relevance and hallucination on logs. But basically what our model does, and we have this expert model that takes in the logs and then compares the user query with each retrieved document, in this case, each retrieved scraped web page, and we make sure that and we answer the question, did this document was this document relevant for the user's query? And we also provide the information about like reasoning, and we make a kind of like a binary determination as to whether it was relevant or it was not relevant. Similarly, for hallucinations, we look at the entire context the model saw. So we looked at the retrieved documents, the user query, and the agent message history, and we look for any facts, any assertions that were not from the output, from that memo, that were not grounded in the inputs. And again, we wanna make sure that is correct. And you can try this at home. This should just work. It's a very straightforward agent. You can swap it out and not make it a different type of agent if you want, because the framework is the same. And you can basically see, hey, if I'm providing dynamic context to my agent, where do things start breaking? Why is this not working? And you can use basically this automatic monitoring that's very easy to check for that in real time, and hopefully like improve your improve your agent over time. Jason, should I pause a bit? I'm going to a different section. I think I've seen the chat questions in chat, so this could be a good time to pause. Or yeah, what do you think? You've seen
I'm pretty interested in this. I would love for you to like go a little bit deeper, and then we can go into some questions afterwards.
Okay, sounds good. So kind of like another example. I'm going to like my two biggest I think the two biggest problem areas I see in agents today. One is hallucinations due to dynamic context, and the other one is actually hallucinations in tool use, which I think people talk about a lot, but they don't think about them as a hallucination, but that's what they are. I think as a theme for this talk is hallucinations you didn't know you were having, but you're having all the time. So this is on the right-hand side. This is actually an example of me trying to put together a Jupyter Notebook cookbook with Cursor last night. And you get these errors if you've ever tried to use Cursor, which is an amazing tool. But if you ever try it and use it on a Jupyter Notebook, it has problems. And it basically says, oh, I tried to call a tool with the incorrect arguments, or I used the incorrect tool. It's struggling, right? And you may not be thinking about like that, but that is also likely a type of hallucination. Because if you think about it, under a hood, there's an LLM that's generating an output that has some information in the output that was not correct, given the information the model received. Like it may be calling the right tool for a job, or it may be like sometimes they even like fabricate like parameter names or tool names. They basically like hallucinate them. So this is another problem that can come up, and this is to the extent like the first one was non-trivial to solve. This one's even more complex because if you try and troubleshoot something like this, like if you're building an agent that uses tools, you'll end up looking at something like this, where let me see what I put here. So on the left-hand side, you get something like, oh, sorry, I didn't want to change the slide. You get something that's like, here are your available tools, and it's this, and it's like a JSON. And then here's the tools that your agent called, like here's your message history. And this is even a simple example because you only have like one user query and one tool call. So this is like as easy as it gets. And if you're looking at this, it took me a while to be like, does this even have a problem in it? And I think the problem was that I even forgot. Like basically there is actually a hallucination in this output. And if I find it, I will tell you, but now I can't find it anymore. Anyway, it's very hard to figure out what the problem is with this tool. But if you look close enough, I promise you, you'll probably find that this has a hallucination somewhere in it. And this is an example of why this is complicated. And you're actually, I'm pretty sure most people on this call have used a coding agent, for example, or some agent that uses tools. You have run into this. And as we have more agents using tools and doing more and more complex tasks, and again, random users using them in random ways, we're into the exact same problem where you have a system that's getting arbitrary inputs and debugging it is completely incomprehensible because you have complex data in, complex data out, and in some cases, you don't even know what went wrong and why. But this is happening. And again, if you're building agents that use tools, you run into this. So so something that my team has been working on is how do you actually catch these tool use issues, some of them which may be hallucinations. You may be, again, hallucinating function names, you may be hallucinating parameters. So actually last week we put out our first model. It's all open weights. It's called Limbic tool use 0.5b. Basically what it does is you send it your list of available tools in your message history from your agent, and it tells you if the tool use was correct, or it used the incorrect tool, or the incorrect parameter names, or the incorrect parameter values. And again, this is another example where we rely on, in this case, a model. At its core, all of these things are judge LLMs to say, hey, was there anything, did the model do something which information, did it fabricate information that it was not supported from the context? And here in this case, part of the context are the available tools. And we actually have a few ones to try it. We have an experimental hosted endpoint for this. I hope, again, the little dinosaur points to just for the docs for this and how you want to use it. It's free. If you want to go on Hugging Face, the weights are available. If you want to self-host. But this is an example of what, again, like starting the conversation of if you go into these more obscure but very prevalent hallucinations and tool uses, how would you go about identifying issues in the outputs? Finally, just because we're coming up on the end and how to get started, I would obviously, hey, I'm the co-founder of Quotient. I'll say, hey, try this out. It's free. You can do it very easily, and you can basically have access to really good evaluators as you're building these agents. And you can basically replicate everything I showed in the notebook, or you can use like this like Limbic model that we put out that, again, it's all open weights and open source. Or you can also do all of this yourself. And if you're working on smaller projects, or if you're just trying things out, I strongly encourage you, you know what, try it yourself first. And because then you'll have a way better understanding of what goes into it and where the problems are. And where, for example, if you're starting to build these evaluators for like document relevance or hallucinations, where you yourself start trusting them less. And I think that's a really important intuition to have. So you can, again, start yourself, build a judge LM. If you're like, I don't know how to build judge LMs, we put out this open source judge library called Judges that basically has research-backed evaluators from the literature. It also has a hallucination evaluator there, and you can get started right away. if you're like, oh, but how do I integrate this with other things? We actually put it in GPT Researcher, which is a deep research AI agent, again, open source. Hope the dinosaur links to it. And basically you can run GPT Researcher, an actual deep research agent, and you can on the go measure your hallucinations, and you'll get like a confidence score and also some reasoning about why that's working, about why a hallucination was detected or there wasn't. But this is again like thinking about, hey, I'm building an actual agent. How do I check for all these things? You have examples here for how to do that. You can do it in like the next half an hour very easily. And I think that's it. Wow, I made it.
Sweet. All right. Thank you so much for
All
that.
right.
Let's jump into some questions right here. I think so. The first question is, where can we find the resources to test the real-time evals for hallucinations? I think we'll just follow up with an email afterwards. That'll include all
Yes.
the, and then if there's anything specific you want to call out, you can just let us know, and we'll put that back in the email.
Yeah.
I guess one question that I think is pretty relevant is from one person. How do you currently reason about the real-time hallucination detection methods? How do they balance the precision versus latency, especially in these like higher stake tasks?
Yeah. So that's why that's a really good question. I think that's when if you bring up the idea of latency, that is the point where having some hosted system that someone else took care of that for you becomes more necessary. So for example, how we solve for the SEC quotient is there are two options. One, you do all these detections asynchronously. So you send a request to our server and you don't hear back from us. Like you hear back from us, but the agent proceeds the same way you would. There's like zero latency impact on the agentic flow. And then and then if you do that, you have the luxury of testing for more things more thoroughly. So you are like, I care about latency to some extent, but given that my agent's not waiting for this answer, then I don't care about it as much, and I can go later in the app or pull the results and check. So you kind of like take the higher accuracy, probably higher latency trade-off. But it's also really good because that's actually the reason, and a lot of people ask me this, oh, like how can your models or your systems like catch hallucinations that a model doesn't? And there are two reasons for that. We have the time to check things more thoroughly. Like our system goes, for example, sentence by sentence in the model output and checks every sentence against every piece of context and makes a determination about whether there was information that was supported. In most agents, in most applications, you don't want to take the time to do that. Now, if you do, the other part of this answer is we are now at a point where we can actually do that part of in the loop evaluation and correctness. And that's actually the reason that was our first experiment with that was actually the Limbic model, because we were able to train a 0.5B model that does over 90%, that has over 90% accuracy in, or I think it was 88%, whatever it was, 90-ish% accuracy in tool use evaluation, which is significantly better than the frontier models out there. And it's a 500 million parameter model, which means that I can put in the loop, because when we put in the loop, it has, I don't know, somewhere between 100 and 200 millisecond latency. And I think we can even get it lower than that. So that is, we're starting to be in the range of we can train very small, specialized evaluator models that are fast and cheap enough to put in the loop. And that's exactly what we're doing now.
That makes sense. And so I guess here, maybe if we run this, 0.5B model and we detect an issue, we might just sort of like almost put that back into the prompt and ask the LLM to try again? Or is it the idea that we want to inject feedback into the language model?
Yeah. So what Given a week, Jason, what we're working on is providing the ability for agents to call Limbic within the loop themselves and then use that information. So you don't have wouldn't. It also makes sense because as a developer, you wouldn't have to be in this process of like manual prompt engineering or context engineering or whatever. Ideally, you want the agent to figure things out more on its own, and that's what we want to happen too.
I think another great question that someone asked is around surfacing to the end users that there's hallucinations that were happening. And so maybe it's a chatbot, it does some generation, and then a hallucination is detected. How have you found teams sort of address those issues? I think in the past, I've seen text be generated and all of a sudden it disappears. Right? What do you think about that?
It depends. I think it's like that's such a important product question actually, because we have a bunch of available options on the tooling side. Like for example, you can just do monitoring and say, I'll let the hallucinations go through and then whatever. It doesn't really matter because no one cares that much about my product or they're very rare or whatever. So I'll want to catch them later on as like a form of monitoring and correct them over time. Or some people are like on the opposite end of the spectrum. They're like, I can never let anything go through. Like I have a medical application, like one of our customers, they're in medical translation, and they absolutely cannot put a hallucination through or any other critical issue through because people take that and they go and that is a dosage for their prescription in Spanish. So that cannot happen. And for them, they're like, oh, I need this, I need a guardrail. And if they need a guardrail, then we are in this like in the loop correction stage where we basically like train guardrails that are extremely fast and extremely accurate. And they they decide where they want to be on the ROC curve for those. And they do something like that. But I think the question is like, where are you? Do you want guardrails or do you want monitoring? Or do you want something in between?
I see. That makes sense. I mean, and then I'm curious, for a big enough company, like would Quotient think about training like specific guardrails for those applications, or do you just sort of have your medical ones and you have the legal ones?
No, absolutely. Like again, the people who are doing this in regulated industries and for agents or API endpoints that go through, I don't know, have like 50 million requests a month or 100 million requests a month, or maybe not that many requests, but again, it's a very, very sensitive area. We can be in this, we do decide sometimes to train custom evaluators. Obviously, like we won't start there, like it doesn't make sense, but sometimes we do end up there, especially if it's something very specific. Maybe something, if you look at foundational models as evaluators, some of them work well. They're good LM judges for some use cases, and for some use cases they're not because they're trained at a strip, didn't have good examples of whatever we want to use them as evaluators for. So it's 100% the case that we work with companies who do want custom evaluators. And I think we're just starting in the last 6 months where we've just started seeing that be worth it, basically, both from an accuracy and a cost and time perspective.
That makes sense. I guess another question someone has is around like citation APIs. I know Cohere and Anthropic have these APIs where you can do citations. What are your thoughts on that generally? Do you feel like that has reduced hallucination rates, or is it sort of almost like a distraction from?
Oh, I'm very pro that. I think we had a citation API endpoint that before Anthropic put out theirs, I was like, shucks, we should have put ours up too when we had it. But I actually think it 100% makes sense. We've been on and off talking about making us public, but I know people prefer. It's still the case that people prefer a lot to have this type of like either go full in or full out. Like they're like, I want guardrails, and then I will catch all these like potential like citation hallucinations and things like that, or I'll just figure things out later when I look at my monitoring dashboard. So that's a long answer for, I think they're really neat and I would use them and I want more people using them, but I don't see it incorporated in a ton of workflows still, which is a bit surprising.
I see. Maybe this sort of leans into the question I ask everyone, which is, I guess for folks who are building in these like higher stake situations where hallucinations are an absolute no, what is something you feel like folks are not thinking about these days and should really ask themselves?
Yeah, I think in this context, it's about how much the context plays into the final output. And I think I peeked at the chat for a second and I saw someone say garbage in, garbage out, and that is 100% correct. I don't know who it was. But yeah, like there are fundamental problems with the data that LLMs won't solve. Like even if you have, I know, if you have AGI or something, it's not the case that they're gonna look in someone's data warehouse and they'll like fix the data for you. Maybe later, but they won't do it initially, right? So there are a lot of problems with the data, and I think there's some, I know, people are more comfortable or like they're kind of ignoring that because like, oh, the agent will figure things out. But sometimes it's basically impossible because the data is incorrect or it's out of date, or like you have multiple documents in your database with exactly the same document but with 3 different numbers. Like people don't look at those and don't know what's wrong, what's correct. So I think the impact of like the underlying context and underlying whether it comes from documents or from the web or from wherever is very, very significant. I think it accounts for 80 to 90% of actual generation problems. It's almost never the prompt. You probably, everyone's very smart who's working on this. You probably did the prompt engineering. It's not the prompt. Most of the time it's your data.
Yeah, I definitely agree there. I feel like one of the big things we talk about in the course is this idea of absence blindness, right? You see tokens come out, and so you think about like, okay, let me figure out how to make the tokens come out better. But people aren't really thinking about what's behind everything else. Is the search good? Is the content good? It's like if you just search for red dresses on a store that has no red dresses, and you get no results, like it's not really anyone's fault. It's just that the inventory is missing. I think that's a big part of how we had to think about providing.
Yeah, like we were working with a company and they're like, it was exactly this, like the model didn't have access to the data, but it was really hard to get to say I don't have access to the data. Like I don't have the information. And that was like a problem for them. I think in the end they solved it by fixing the data problem. But
yeah, how do you tend to detect that? Like in the past, I've looked at things like monitoring like average cosine distance of certain question segments, or looking at the re-ranker results and saying, hey, if everything is low, maybe something is up.
Yeah, honestly, that's an interesting point. I think that might be a good way of doing it in the loop. If you want to do it not like that, like if you want to do it very highly with higher accuracy, but like a lot of like higher cost, you can do that brute force approach that I said, where you like take, I don't know, whatever accounts for 90% of your user queries and put them through like brute force your database with like a judge LM that figures out something. But that's, again, you can't do that all the time. It's actually way simpler to figure it out for tool use, because you just look at the list of available tools and you're like, like you straight up don't have the tools to answer this in the model. I think Limbic, Limbic can basically say, use the incorrect tool. But you can figure that out there because like your corpus is like a little JSON.
Yeah, I'm glad someone is talking about sort of inventory issues. I feel like most companies are thinking about like prompting and like using a better LLM, but it is very much the case that if you just don't have the inventory, data quality is very important. And the easiest way of figuring that out is synthetic data generation, brute force.
Yeah, I mean, I know. You saw in my bio that I started when all of this was called data science, and it's the same problems. Like 10 years ago, people are like, make me a model, but their data was not great. Same problem.
Yeah. It's like $20 to fine tune the language model. It's like $100,000 to get the CSV file.
Yeah, exactly.
Awesome. Julia, thank you so much.
Thank you for everyone for joining.
Thank you so much. Take care, everyone.